Welcome to 7.5, Trapezoids and Kites. A trapezoid is a quadrilateral with exactly one pair. And what's key here is that you understand it's one pair, not both sides. One pair of parallel sides. Those two sides are going to be called your base. Okay? Now, it's a four-sided figure, so all the interior angles add up to 360 degrees. So when you have a isosceles trapezoid, your 360 degrees, the base angles are the same on the bottom, and they're the same on the top. Those are just some things you got to point out. Let's do some problems here, and we'll figure out these things. Here's the theorems. Isosceles trapezoid means just like an isosceles triangle, the two sides are the same, and that's what we have here. And I already talked about the angles. So that's the isosceles trapezoid base angles theorem. Your angles are the same. Isosceles trapezoid base angles converse is if you have two sides that are the same and one pair of base angles that are the same, then you have an isosceles trapezoid. Okay? And then the last one here, isosceles trapezoid diagonals theorem. In an isosceles trapezoid, you have one if the diagonals are congruent. So AC is going to be the same length as BD. So those are some important things to note about isosceles. Okay, W is at 1, 4. 1. Let's see here. 1, 1, 2, 3, 4. W. X is at 1, 8. 5, 6, 7, 8. Y is at negative 3, 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And Z is at negative 3, 3. Negative 3, 1, 2, 3. Okay, so if we connect those, we see we have a trapezoid because these two are parallel. And then the next question is, what else do we know? So if you have two parallel sides, then you have opposite sides are parallel. Okay, these are opposite sides. They are parallel to each other because they're undefined. The slope is undefined. You could say that, all right? And that's all you need for a trapezoid. The definition of a trapezoid is you have one pair of parallel sides. So let's do this one. Negative 3, 3. 1, 2, 3. 1, 2, 3. That's D. Negative 1, 1 is E. 1, negative 4. 1, 1, 2, 3, 4. That's F. G is at negative 3, 0. All right, so what do we have here? The question is, do we have two pairs of opposite sides that are parallel? So let's go D to E, the slope of D to E. Okay, so we're going down. We go down 1, 2, and over 1, 2. So down 2 is negative 2 and over 2. So that's negative 1. What about the slope of GF? G to F, we go down 1, 2, 3, 4, and over 1, 2, 3, 4. So down 4 and over 4, that's negative 1. So yes, those two are parallel. So DE is parallel to GF, so by definition, that is a trapezoid. All right, negative 2, 0 is M. 0, 4, 1, 2, 3, 4 is N. 5, 4, 1, 2, 3, 4, 5, 1, 2, 3, 4. That would be P. And 8, 0, 6, 7, 8. That's Q. All right, so let's do this in blue here. Well, there's your two parallel sides there. So that's those two slopes. The slopes of both of those is 0. When it's flat like that, it's 0. Vertical is undefined, flat is 0. So yeah, those are that's a trapezoid. Okay, now 1, 9, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9 is H. 4, 2, 2, 3, 4, 1, 2 is J. 5, 2, 5, 2 is K. And 8, 9, 6, 7, 8, 9 is L. Well, we know already, just visually, that we have two parallel sides, okay? And this is an isosceles trapezoid because these two lengths are the same. You'd have to show distance, but you can also use slope. 1, 2, 3, 4, 5, 6, 7, up 7, and over 1, 2, 3. So you go up 7 over 3. The other one should be negative. Up 1, 2, 3, 4, 5, 6, 7. So that's 7. And to the left, 1, 2, 3, negative 3. So because you went up the same distance and across the same distance, that means those distances are the same. So just by looking at slope that hasn't been reduced, we know that's isosceles trapezoid. Okay, so what's important here is we have isosceles trapezoid. That means these two sides are the same, and the angles attached to the parallel sides are the same. So let's look at number 5. So that means angle J, the measure of angle J, is 118 degrees. So it's not consecutive like in a parallelogram. These two are consecutive, okay? Those two are consecutive, and opposite angles are the same. And those are consecutive, and those are consecutive. Again, opposite angles are the same in a parallelogram, but we don't have a parallelogram, okay? So we do have something different, that consecutive angles, in this case, are still going to be different, but what do they add up to? Let's figure all these out. You do have two parallel lines cut by this transversal. So technically, these are consecutive angles. Okay, so if that's 118 degrees, the measure of angle L is going to be what? 180 minus 118 is 62. Okay, and that means the measure of angle M is 62 as well, because those two are the same. Okay, the other way to do this is you have 118 degrees at K and J. So 118 and 118 is 236. There's 360 degrees in a triangle, so that leaves 124 degrees left. And since those two are the same, we divide that by 2, and we get 62 degrees to split between them. So you could do it that way, or you could use your consecutive angles rule. So let's look at number 6. It's upright. That's a little easier to do. So angle R and angle S are the same. So the measure of angle R is 82 degrees. And angle T is consecutive to angle S. So 180 minus 82 is 98 degrees, which means angle Q and angle T are the same in isosceles trapezoid. All right, mid-segment theorem. So here what this means is that AB and CD, the top and bottom, or I should say the parallel lines in a trapezoid, if you add those lengths together, and then you divide it by 2, you'll get the length of the mid-segment. All right, let's do some homework. Number 7, find the length of the mid-segment. So what is MN? So the distance of MN, is equal to 18 plus 10, the two parallel sides added together, and then you divide by 2. So 28 divided by 2 is 14. Okay, again, the distance of MN is the two parallel lines divided by 2. So 76 and 57 is 133. Divide by 2. That's going to be 66.5. Okay. Now, find AB. Now, this is not the mid-segment. You're wanting the other parallel line here. Okay? So again, the distance of AB is equal to something. So let's start with the mid-segment. The distance of the mid-segment is the two parallel sides, 10 plus AB, divided by 2. All right? Well, we do have the distance of the mid-segment. It's 7. So 7 equals the two parallel sides added together divided by 2. So how do we solve for AB? Well, you can't have the 2 here, so let's multiply to get it out on both sides. So the 2's reduce out on the right, leaving 10 plus AB. And we have 14 on the left now. Subtract 10, and you get 4 is AB. Again, number 10, the distance of the midsegment, MN, is the two parallel sides, 11.5 plus AB over 2. The midsegment is 18.7, and 11.5 plus AB over 2. So we multiply by 2 to get rid of the denominator. And 2 times 18 is 36. 2 times 0.7 is 1.4. So 36 and 1.4 is 37.4. Or use your calculator. And now we subtract 11.5. So borrow 14 minus 5 is 9. Drop the, you got to match up your decimals. Drop the decimal down. And then you got a 6 here. 6 minus 1 is 5. 3 minus 1 is 2. So 25.9 is AB. That's how you do those. Now let's find the length of the midsegment, but first we have to draw it. So we do the exact same thing we've been doing. So 0, 0 is S. Okay. 2, 7. 1, 2, 1, 2, 3, 4, 5, 6, 7 is T. 6, 10. 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's U. And V is at 8, 6. 7, 8. 1, 2, 3, 4, 5, 6 is V. So here is our trapezoid. All right. So it says it's a trapezoid. How do we find the midsegment? Well, we need to know where the midpoints are so we can connect them. All right. So first, you got to find the midpoint of ST. Midpoint of ST. So you take S and T and you add your X's. 0 plus 2 over 2. Add your Y's. 0 plus 7 over 2. So we get 2 over 2 is 1. 7 over 2 is 3.5. Okay, so at 1, 3.5. 1, 2, 3 and a half. That's where it's supposed to be right there. Now the midpoint of UV. So 6 plus 8 over 2 and 10 plus 6 over 2. 14 over 2 is 7. 16 over 2 is 8. So 7 is right here. 8. 1, 2, 3, 4, 5, 6, 7, 8. So my lines aren't perfectly drawn. That's the midpoint. That's why we need to use rulers and accurate graphs. We have an accurate graph, but I didn't draw my lines very straight. Okay, so now we have those two midpoints. What's the length between those? So we use the distance formula. Distance formula from those points we'll call, we'll just do it here. So x minus x, I'll do 7 minus 1 squared. And y minus y, 8 minus 3.5 squared. 7 minus 1 is 6. 8 minus 3.5 is 4.5. You got to square those. So you're looking at the square root of 36, and 4.5 squared is 20.25. Use your calculator. All right, 36 plus 20.25 is the square root of 56.25. All right, so we got to take our calculator and do the square root. Let me see here. Square root 56.25 on my calculator. It's going to be 7.5 rounded. Okay, so let's do another one. 0, 3, 1, 2, 3. That's going to be A. 2, 5, 1, 2, 1, 2, 3, 4, 5. 6, 4, 3, 4, 5, 6, 1, 2, 3, 4 is C, and 2, 0 is D. Connect them alphabetically so you don't make some weird picture. All right, so this is a trapezoid. Try to draw them straight because we got to find the mid segment. So, all right, so our midpoint, let's see, AB is parallel to DC, obviously. So we need our midpoints here. So midpoint of AD is take A and D, add the X's, divide by 2, add the Y's, divide by 2. So we get 2 over 2 is 1, 3 over 2 is 1.5. Now we need the midpoint from B to C. And so 2 plus 6 over 2, and 5 plus 4 over 2. So 8 over 2 is 4, 9 over 2 is 4.5. Now we can graph it. 1.5 is right there. Let's use blue. right there, and 4, 4.5. 4, 1, 2, 3, 4.5. So there's your midpoint, or your mid-segment. Let's find the distance there. So 4 minus 1, subtract your x's, subtract your y's. 4.5 minus 1.5. 4 minus 1 is 3. 4.5 minus 1.5 is 3. So that is the square root of 9 plus 9, or the square root of 18. So use your handy dandy calculator and take 18, take the square root of 18, and that's 4.24. All right, but also you need to be able to do this. That's 3 square root of 2. Exact answer is 3 square root of 2. The rounded answer is 4.24. Oops. 13. 2, 0. That's A. 8, negative 4. 1, 2, let's see, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. That's B. Okay, barely on the screen here. And C is at 12, 2. 9, 10, 11, 12, 1, 2. And 0, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow. Sorry about that. And obviously my lines are not going to have the right stuff on them. Okay, so our midpoints, let's find those. And we'll go midpoint of A to D. Again, use A and D. 2 plus 0 over 2, and 0 plus 10 over 2. So that's 2 over 2 is 1, 10 over 2 is 5. And the midpoint of BC, 8 plus 12, add your x's, divide by 2, add your y's, divided by 2. 20 over 2 is 10, negative 2 over 2 is negative 1. All right, so let's put those together. 1, 5, 1, 1, 2, 3, 4, oops, 5 right there. And 10, negative 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative 1 right there. So there's your mid-segment. So again, distance is 10 minus 1, x minus x, y minus y, negative 1 minus 5. 10 minus 1 is 9. Negative 1 minus 5 is negative 6. When you square a negative, it goes away to positive. 81 and 36 is 110, 117. So that's an exact number. And use your calculator to do the square root of 117, and you get 10.82. So 10.82. Okay, negative 2, 4. Negative 1, negative 2. 1, 2, 3, 4 is S. Negative 2, negative 4. 1, 2, 3, 4 is T. That's a vertical line. And 3, negative 2. 1, 2, 3. Negative 2 is U. And 13, 10. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. Wow. All right. So those are your two parallel lines. Somewhere in here is our midpoints. So let's start our midpoint quest. ST. S and T. So negative 2 plus negative 2 over 2. And 4 plus negative 4 over 2. So negative 2 is negative 4. Negative 4 over 2 is negative 2. 4 plus negative 4 is 0 over 2 is 0. So negative 2 is 0, right there on the x-axis. All right, now the midpoint of UV. 3 plus 13 over 2. And negative 2 plus 10 over 2. 16 over 2 is 8. Negative 2 plus 10 is 8 over 2 is 4. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. There's your mid-segment. Now let's do the distance. Negative 2 minus 8. And 0 minus 4. Negative 10 squared is going to be a positive 100. And that's negative 4. Negative 4 squared is positive 16. So this is going to be the square root of 116. So let me put this right square in the middle here. The exact answer, square root of 2, excuse me, and 58. And we can break apart 58, the square root of 2, and 29. All right, so that is just the square root of 4, which is 2. So the exact answer is 2 square root of 29. That's one of them. 2 square root of 29. And what is the square root of 116? Would be approximately 10.77. Okay, so we talked about trapezoids and mid-segments. Now let's talk about kites. So a kite has two pairs of consecutive congruent sides. That just means they're not opposite congruent, okay? So those two are congruent, and then these two are congruent, obviously. Opposite sides are not congruent. So an opposite side means not touching each other. So those are not congruent, and those are not congruent. Okay, kite diagonals theorem. The diagonals are perpendicular, okay? And opposite angles theorem, the only angles that are congruent are those two. Angle B and angle D are not congruent. But a kite has four sides, so interior angles add up to 360. That's important. Okay, find the measure of angle G. Okay, so here you go. There's 360 degrees in a kite. Subtract that 140, and we get 220. And remember, E and G are the exact same. They're the same measurements. So we just divide this by 2, and the measure of E and G is 110 degrees. Okay, same thing. E and G here are opposite each other in between the two congruent sides here. So obviously those two are not the same. So E and G have to be the same. So 150 and 90 is 240. Subtract that from 360 and you get 120. Divide that by 2 because E and G are the same. And E and G are both 60 degrees together. Okay, so now they switch it up. In the kite, H and F are the same. So the measure of angle F is 110 degrees. So what do you get for G? Do not say the measure of angle G is 60. That's not right. Okay? E and G, in this case, are the angles that do not match. So there's 360 degrees in a triangle. Subtract the 110, 220, because we know both those are 110 degrees. F and H. F plus H is 220 degrees. And E is 60, so we got to subtract 60 as well. So we're going to take 360 minus 280, which is the 220 and 60 together. And that will be the measure of angle G, which is 80 degrees. Not the same as angle E. Okay, again, H and F, those are the ones that are the same. So the measure of angle H must be 90 degrees. So how do we get G? G is not the same as angle E here. Do not say that that's 110 degrees. That's wrong. Okay, so you have 360 minus 90, 90, minus another 90, minus the 110. So those three together, 110, 290. So 360 minus 290. Or just use your calculator. Okay, and that is going to be 70 degrees. So the measure of angle G is 70 degrees. Okay, so let's just go ahead and solve the problem without looking to see what they did. So the mid-segment of MN is equal to the parallel sides divided by 2. Well, the mid-segment is 8. So you do have to correct the problem, so we might as well just do the problem as is and then look to see what they did wrong. So multiply by 2, we get 16 equals 14 plus DC. Subtract 14, and we get 2 is the length of DC. Okay, so what they do wrong? They took AB, which is 14, and subtracted the mid-segment, which is totally not what you're supposed to do. Okay, you're supposed to take the parallel sides and divide by 2. So they totally just screwed this up, thinking they knew what the mid-segment was. Yeah, 14 minus 8 is 6, but that's not the formula of how you get those. So again, the best way to do this is try not to look at what they're doing and just solve the problem. So let's just find angle A and angle D. Well, we know that those two are the same. How do I know those are the same? The angles between the single hash mark and the double hash mark, okay? The angle that makes those two are the same degrees, okay? Notice that you have two double lines here, so that 50 degrees is not the same as the angle made by the two single hash marks, angle A. Okay, so the measure of angle D is 120 degrees. And again, so you take 360 minus 120 minus angle D, 120, and minus angle C, 50. And that will give you the measure of angle A. Okay, so 120 is 240, and 50 is 290. So 360 minus 290 is going to be 70 degrees. All right, so what did they do? They said the measure of angle A was 50. So they did the typical student error and said that those two are the same. So no, it's the two angles between the two hash marks that are different. So 120 and D are the same. And that's the end of your homework. So good job.